What if everything you've ever seen was wrong? Not your memories, not your opinions, reality itself. Right now, you're looking at a screen. It feels obvious, solid, immediate. You trust what you see without even thinking about it. After all, your eyes are showing you the world. Or are they? Imagine for a moment that everything you call reality is actually the final version of a story, edited, rewritten, and completed before you ever become aware of it. It sounds impossible, but modern neuroscience has uncovered something extraordinary. Your brain is not a camera. It is not recording the world. In fact, your brain never has access to reality itself. All it ever receives are tiny electrical signals, silent, colorless, meaningless on their own. Somehow, from those signals, your brain creates color, sound, faces, movement, distance, time, even the feeling that you're here, right now. Everything you have ever experienced, every sunset, every smile, every star in the night sky, has existed only after your brain transformed electrical activity into a conscious experience, which raises a disturbing possibility. Perhaps you've never experienced the world directly. Perhaps you've only experienced your brain's version of it. And if that's true, one question changes everything. Then what exactly are your eyes doing? Your eyes feel like windows, transparent, honest, faithful. Every moment of your life, you've trusted them without question. But here's something almost impossible to believe. There is a hole in your vision. Right now. Not later. Not only in darkness. Right now. Every human being has one. And yet, almost nobody has ever seen it. The reason is hidden inside your eye. Your retina is covered with millions of light-sensitive cells called rods and cones. They capture light and convert it into electrical signals. Those signals travel through more than 1 million nerve fibers, forming the optic nerve. But there's a problem. The optic nerve has to leave the eye somewhere. And where it does, there are no photoreceptors, no rods, no cones, no vision. Scientists call this region the optic disc. Most people know it by another name, the blind spot. If an object falls exactly there, your eye doesn't see it at all. Not poorly, not blurry, completely invisible. You would expect to see a black hole floating in front of you, but you never do. Why? Because your brain refuses to show it to you. Instead, it quietly fills in the missing information, perfectly, instantly. If the missing area contains blue sky, your brain paints more blue sky. If it contains grass, it invents more grass. If a straight line passes through the blind spot, your brain simply continues the line, as if nothing were ever
The brain
missing.
builds reality from
You
independent
don't
pieces,
notice the correction,
edges, movement,
because the
color,
correction becomes
and
your
then it all
reality.
synchronizes into one
And
seamless
this
visual
isn't a
world.
rare trick. It's happening every second of your life. But the blind spot is only the first surprise. Here's another. You probably think your eyes move smoothly across the world. They don't. Instead, they make rapid jumps called saccades. 3, 4, sometimes 5 times every second. Each jump happens so quickly that if a camera copied exactly what your eyes recorded, the video would look chaotic. The world would shake violently. Everything would blur. Reading would become almost impossible. Yet, that's not what you experience. During every saccade, something remarkable happens. Your brain temporarily suppresses visual awareness. Scientists call this saccadic suppression. For a tiny fraction of a second, Your brain simply stops showing you visual information. Then, once your eyes reach their new position, your brain stitches the next image onto the previous one, like an invisible film editor, cutting out every shaky frame. Imagine watching a movie where thousands of frames are silently removed, yet the motion still looks perfectly smooth. That's essentially what your brain does, every waking moment. You never notice the missing frames. You only experience the finished version. Think about what that means. Every second, your brain hides a blind spot, removes the blur created by your eye movements, repairs missing information, smooths over interruptions, and presents everything as one seamless reality. Not because that's what your eyes captured, but because that's the story your brain decided to tell. If your brain can erase a hole in your vision, remove moments when you're effectively blind, and make everything appear perfectly continuous, how much of what you call reality was actually created inside your own head? But filling in missing information is only the beginning. So far, we've discovered something remarkable. Your brain quietly repairs reality. It hides your blind spot. It removes the blur created by your own eye movements. It edits the world before you ever become aware of it. But what if that's only the beginning? What if your brain isn't just repairing reality, but actually creating parts of it? Let's find out. Imagine you're looking at a simple drawing, 3 incomplete circles, 3 black angles, nothing else, no triangle. And yet, almost everyone instantly sees one. A bright white triangle floating in front of the image. But look closer. There are no white lines, no edges. No triangle was ever drawn. Your brain created it. This illusion is known as the Kinesa triangle. It reveals something extraordinary. Your brain hates incomplete information. When reality leaves gaps, your brain fills them, even if it has to invent something that was never there. Now let's try another experiment. Look at a checkerboard. One square appears dark, another appears light. They look completely different. You would probably bet money they're different colors. They're not. They're exactly the same shade of gray, pixel for pixel. This famous illusion, created by vision scientist Edward Adelson, demonstrates that your brain doesn't simply measure light, it interprets it. Your visual system assumes one square is sitting in shadow. So, without asking your permission, it brightens that square in your conscious experience. You never see the raw image. You see your brain's best explanation of the image. That ability is incredibly useful. Without it, a white shirt would constantly change color every time the lighting changed. But sometimes, your brain's explanation becomes more convincing than reality itself. Now consider a human face. Turn a face mask inside out. Logically, you should see a hollow face, but almost nobody does. Instead, the face suddenly bulges outward. As you move, it even appears to follow you. Why? Because your brain has spent your entire life learning one simple rule. Faces stick out, not in. That expectation is so deeply wired that your brain ignores the actual shape in front of your eyes. Expectation defeats reality. And vision isn't the only sense your brain can rewrite. Listen to someone clearly saying ba. Now watch a video where their lips are forming ga. Something astonishing happens. Many people hear da, a sound that was never spoken. This phenomenon is called the McGurk effect. Your ears heard one sound, your eyes saw another. Your brain refused to choose between them, so it created a completely new perception. Reality was negotiated, not received. But perhaps the strangest experiment of all involves something disappearing right in front of your eyes. Researchers show volunteers two nearly identical photographs. Between them, there's a brief blank screen. During that tiny interruption, something changes. A person disappears. A building changes. A door changes color. Most people never notice, even when they're staring directly at the object. This is known as change blindness. It reveals something deeply unsettling. Your brain does not build a perfect copy of the world. It builds a useful summary. The details it considers unnecessary are often never stored at all, which means the incredibly rich world you believe you're constantly experiencing is, in many ways, an illusion of completeness. Your brain isn't showing you everything. It's showing you what it believes matters most. Think about what we've discovered. Your brain invents shapes that don't exist, changes colors, ignores real geometry, combines different senses into entirely new experiences, hides massive changes occurring right in front of your eyes. And somehow, all of this happens inside a perfectly healthy brain. Not because something has gone wrong, but because this is exactly how perception normally works, which raises an even bigger mystery. If your brain spends so much effort changing reality, why would evolution build such a system? We've seen that your brain fills in missing information. It invents shapes. It changes colors. It even creates sounds that never existed. But all of those discoveries lead to one unavoidable question. Why? Why would evolution build a brain that constantly changes reality instead of simply showing it as it is? For decades, neuroscientists were asking exactly the same question. Then, a remarkable idea began to emerge. Not from one experiment, not from one laboratory, but from decades of research across vision, movement, perception, and cognition. Today, it has become one of the most influential frameworks in modern neuroscience. It's called predictive processing. The idea is surprisingly simple. Your brain does not begin with the outside world. It begins with a prediction. Every fraction of a second, before new sensory information has even been fully processed, your brain is already asking, what is most likely to happen next? It predicts what you'll see, what you'll hear, what you'll feel, where objects will move, what another person is about to say, even where your own body will be a moment from now. Then reality arrives. If reality matches the prediction, almost nothing needs to change. Your brain simply says, exactly as expected. But when reality doesn't match, something extraordinary happens. Your brain generates what neuroscientists call a prediction error. A prediction error is simply the difference between what your brain expected and what actually happened. That tiny difference becomes incredibly valuable. Because instead of rebuilding the entire world from scratch, your brain only needs to update what was wrong. Imagine opening the front door of your own house. Before you've even looked around, your brain already knows what's inside. The couch, the table, the kitchen, the hallway. You don't consciously examine every object every morning. You don't need to. Your brain predicts almost the entire room before your eyes finish scanning it. Now imagine someone secretly moved your refrigerator into the middle of the kitchen. For a split second, something feels deeply wrong. You stop. You stare. Your brain has just encountered a massive prediction error. The world no longer matches its internal model, so the model must change. Or think about something even simpler. You're holding your favorite coffee mug. Every morning, it feels the same. Your brain already knows how heavy it is. One day, someone secretly empties it. You lift the mug and your hand flies upward. Not because your muscles failed, but because your brain predicted a heavier object. Your movement began before the real information arrived. Or picture yourself walking upstairs late at night. You've climbed these stairs hundreds of times. Without thinking, your brain predicts the next step. Your foot rises, expecting solid ground, but the staircase has already ended. Suddenly, your entire body jerks. For a brief moment, it feels as though gravity itself has changed. Almost everyone has experienced this. That strange sensation isn't caused by the missing step itself. It's caused by a failed prediction. Your brain confidently prepared for a future that never happened. Once you begin looking for prediction, you start seeing it everywhere. You finish people's sentences. You anticipate the next note in a familiar song. You instinctively know where a bouncing ball will land. You reach for a light switch without looking. Your life doesn't feel like a constant stream of predictions because successful predictions are invisible. You only notice them when they fail. And that's what makes this idea so fascinating. According to predictive processing, your brain is not primarily reacting to reality. It's continuously trying to stay one step ahead of it, which leads to an astonishing possibility. Maybe perception isn't built from the outside, inward. Maybe it begins inside your brain, and reality is constantly correcting it. But prediction creates a much bigger mystery. So far, we've talked about predictions, but we've skipped one crucial step, the most mysterious step of all. What actually happens between the moment light enters your eyes and the moment you become aware of seeing? It feels instantaneous, but it isn't. Imagine a single photon, one tiny packet of light leaving a distant star. It travels across space, through Earth's atmosphere, into your eye. It passes through your cornea, then the pupil, then the lens, which bends the light, focusing it onto the retina. Up to this point, nothing has been seen. There are no colors, no shapes, no awareness, only physics. Then, something extraordinary happens. Deep inside your retina, millions of microscopic cells absorb tiny particles of light. Each photon triggers a chemical reaction. That chemical reaction becomes an electrical signal, the language of your nervous system. In a fraction of a second, millions of these signals begin racing toward your brain. But here's something almost nobody realizes. The optic nerve isn't a video cable. It doesn't transmit pictures. There are no tiny images traveling through your head. No colors, no landscapes, no faces. Only patterns of electrical activity. Millions of neurons, firing, stopping, firing again. Imagine disconnecting a camera from a computer. Inside the cable, there are no photographs, only electrical pulses. Somehow, the computer reconstructs the image. Your brain faces an even greater challenge, because unlike a computer, it never receives the original picture. It receives only fragments, tiny pieces, edges, contrast, motion, brightness. Small clues arriving through separate neural pathways. Different parts of the visual cortex begin working at the same time. Some neurons specialize in edges. Others detect movement. Others respond to orientation. Others analyze depth. Others compare colors. None of these neurons sees the whole picture. No single neuron knows you're looking at a face, or a tree, or the night sky. Somewhere, out of billions of electrical signals, a complete world suddenly appears. And neuroscience still cannot fully explain how that happens. Researchers can watch neurons fire. They can map visual pathways. They can identify specialized brain regions. But there is still no accepted explanation for how electrical activity becomes conscious experience. How do neurons become the color blue? How do electrical impulses become the smell of coffee? the sound of rain, the face of someone you love. This mystery has a name. Scientists call it the hard problem of consciousness. We understand more about the brain today than at any other time in history. We know how neurons communicate. We know how visual information travels. We know many of the computations taking place inside the cortex. But the moment when information becomes experience remains one of science's greatest unanswered questions. Somehow, somewhere between photons, electrical signals, and billions of communicating neurons, the universe becomes your universe. Not the universe as physics describes it, but the one you see, the one you hear, the one you touch, the one you call reality. And if consciousness itself is built on top of predictions, then one extraordinary question still remains. Why is prediction so much better than simply reacting to the world? Imagine standing at home plate. A professional pitcher winds up. The stadium falls silent. Then, the ball leaves his hand. In less than half a second, it will reach you. Almost 100 miles per hour. Faster than your conscious mind can fully understand. Yet, major league hitters make contact. Again and again. How? It certainly isn't because their eyes are faster than yours. In fact, the biology of the human nervous system places strict limits on all of us. The moment light reflects from the baseball, it begins a remarkable journey. First, photons strike your retina. Chemical reactions begin. Electrical signals are created. Those signals race through the optic nerve. Multiple areas of your brain analyze them simultaneously. Motion, direction, speed, distance. Then, another part of your brain plans a movement. Motor commands travel down your spinal cord. Finally, your muscles begin to contract. All of this happens astonishingly fast, yet not instantly. By the time your brain has finished reacting, the baseball has already traveled several more meters. If hitting a baseball depended only on reaction, nobody would ever hit one. Professional players know this instinctively. They don't swing where the ball is, they swing where it will be, long before the ball arrives. Tennis players do exactly the same thing. A serve can exceed 140 miles per hour. There isn't enough time to watch the ball, analyze it, decide, and then react. Instead, the brain begins predicting the trajectory almost immediately after the racket makes contact. Tiny changes in the opponent's posture, the angle of the racket, the speed of the swing, all become clues. Your brain combines them and generates its best estimate of the future. Even ordinary driving depends on the same principle. Imagine you're approaching an intersection. A child is standing near the curb. A cyclist is approaching from your left. Another car is slowing ahead. You aren't consciously calculating hundreds of possibilities. Your brain is doing it automatically. Every second, it predicts what each person is most likely to do next. Will the child run? Will the cyclist turn? Will the driver brake? Without those predictions, safe driving would be impossible. And scientists have found fascinating evidence that prediction affects perception itself. One famous experiment is called the flash lag effect. Participants watch a moving object and a brief flash of light. Physically, both occupy exactly the same position at exactly the same moment. But that's not what people report seeing. Almost everyone perceives the moving object slightly ahead of the flash. It's as though the brain has already begun placing the moving object into its expected future position. Researchers continue to debate the precise mechanisms behind this illusion, but the experiment reveals an important truth. Motion is processed differently from stillness. A moving world cannot be understood by simply waiting. It has to be anticipated. Think about something as simple as catching your phone when it slips from your hand. You don't consciously solve equations. You don't calculate gravity. You simply move, before you even realize you've decided. Or imagine walking through a crowded train station. Hundreds of strangers move in every direction. Yet somehow, you weave between them without thinking. Your brain is constantly predicting hundreds of tiny future movements. Most of those predictions are correct, which is exactly why you never notice them. Prediction is invisible when it works. You only become aware of it when it fails. When you miss the last step. When someone unexpectedly stops in front of you. When a tennis ball clips the net. When the coffee cup is lighter than you expected. Every surprise is a failed prediction. Every smooth movement is a successful one. Suddenly, something extraordinary becomes clear. Evolution wasn't trying to build a brain that reacted perfectly. It was trying to build a brain that reacted first. Because in a fast-moving world, waiting for complete certainty is already too late. Reaction is too slow. Let me ask you a simple question. What color is an apple? Red? It certainly looks that way. But here's something that sounds impossible. There is no such thing as red. Not outside your brain. In fact, there is no color anywhere in the universe. Physics has never found it. Space contains no redness, no blueness, no greenness. Only light. More precisely, electromagnetic waves. Different wavelengths, different amounts of energy, that's all. A beam of light has no idea it's red. The photon doesn't carry color with it. Color appears only after that light reaches a nervous system capable of creating the experience. Somewhere around 700 nanometers, your brain produces red. Around 530 nanometers, it creates green. Around 450 nanometers, blue. The colors feel as though they belong to the world, but they belong to your perception of the world. Imagine a universe with no eyes, no humans, no birds, no insects, no living creature capable of vision. Would red still exist? According to physics, no. Only electromagnetic radiation would remain. Color is not discovered, it's created. But colors aren't unique. The same hidden process happens with every one of your senses. Think about sound. You love music. You recognize voices. You hear thunder rolling across the sky. But outside your ears, there is no sound. There are only tiny waves of changing air pressure, silent, invisible, meaningless. Your ears convert those vibrations into electrical signals. Your brain transforms them into Beethoven, rainfall, laughter, a mother's voice, even silence itself. Now think about taste. Chocolate, coffee, fresh strawberries. None of those flavors exist inside the food. The food contains molecules. Those molecules bind to specialized receptors on your tongue. Electrical signals travel to your brain, and only then sweetness appears. Bitterness, saltiness, sourness, umami. Flavor is not hidden inside the apple. It emerges inside you. Temperature works the same way. Hold a cup of hot coffee, then touch a cold window. It feels as though heat and cold are properties of the objects themselves, but your skin never detects hot or cold. It detects changes in thermal energy. Specialized receptors send electrical signals to your brain. Your brain interprets those signals as warmth or cold. Even pain isn't simply found in the outside world. Pain is an experience your brain constructs from signals that suggest potential or actual damage. Everything begins to look different. Color, sound, taste, temperature, pain. None of them exist as conscious experiences outside a brain capable of creating them. The outside world is real, but the world you experience is a translation, a biological language, a user interface built by evolution. Suddenly, one extraordinary idea begins to emerge. You have never experienced the universe exactly as it is. You have only experienced the version your brain allows you to perceive. And if every sensation is a construction, then what exactly is reality? Let's take one final step. Forget color, forget sound, forget taste. Imagine reaching out and touching the table in front of you. It feels solid, hard, real. There is no doubt in your mind that your hand has made contact with the table. But something extraordinary is happening. In reality, your hand never actually touches it. Not in the way you imagine. At the microscopic level, both your hand and the table are made of atoms. And atoms are astonishingly empty. If the nucleus of an atom were the size of a marble, the nearest electrons would orbit dozens of meters away. Almost everything in between would be empty space. In fact, more than 99.99999999999% of an atom is empty. Which raises a strange question. If atoms are mostly empty, why can't your hand pass straight through the table? The answer is invisible. As the atoms in your hand approach the atoms in the table, their negatively charged electrons begin to repel one another. At the same time, the laws of quantum mechanics prevent electrons from occupying the same quantum state. What you experience as touch is actually an immense electromagnetic interaction happening between trillions upon trillions of atoms. Your brain receives signals from pressure receptors in your skin. It converts those signals into the unmistakable feeling of touching something solid. But the sensation itself exists only in your conscious experience. The universe contains electromagnetic forces. Your brain creates solidity. Think about that for a moment. Every handshake, every hug, every raindrop on your skin, every key you press, every page you've ever turned, every object you've ever held, every mountain you've climbed, every grain of sand beneath your feet. None of them were experienced directly. They were translated by your nervous system. The universe never whispered, "This is soft, this is rough, this is smooth." Those experiences were created inside you. The same is true for weight, texture, pressure, balance. Your brain takes invisible physical interactions and transforms them into the rich world you call reality. Suddenly, something remarkable becomes clear. The universe you experience isn't the raw universe described by physics. It's a beautifully simplified interface, a translation, a model. Just as your computer desktop doesn't show you billions of electrical transistors, your brain doesn't show you quantum fields, electromagnetic forces, or subatomic particles. It shows you colors, sounds, faces, trees, tables, friends, a world that is easy to understand and fast enough to survive in. Perhaps that's the greatest achievement of the human brain. It transforms an unimaginably complex universe into a world you can navigate without ever thinking about it. But this realization leads to one final mystery. If your brain constructs every moment of conscious experience, what happens when that construction continues, even without the outside world? So far, one idea has appeared again and again. Your brain predicts. It edits. It fills in missing information. It builds an internal model of reality. But now, let's ask the strangest question of all. What happens when the outside world almost disappears? Every night, you experience exactly that. You close your eyes. External sensory input is dramatically reduced. And yet, an entire world appears. You walk through cities. You speak to people. You hear music. You feel fear, joy, surprise. Sometimes, you even believe you're awake. Until you wake up for real. Dreams reveal something extraordinary. Your brain doesn't need the outside world to generate conscious experience. Given the right conditions, it can create an entire reality on its own. Streets, faces, voices, entire conversations, complete stories. None of them physically exist. Yet while you're dreaming, they feel completely real. This brings us to one of the most fascinating ideas in modern neuroscience. An idea proposed by neuroscientist Anil Seth. Seth is a professor of cognitive and computational neuroscience at the University of Sussex. For years, he has studied one of science's greatest mysteries, consciousness. While explaining how perception may work, he introduced a phrase that immediately captured worldwide attention. He described our everyday experience as a controlled hallucination. At first, that sounds shocking, but it doesn't mean that the world isn't real, nor does it mean that healthy people are constantly hallucinating in the medical sense. The word controlled is the key. According to Seth's interpretation of predictive processing, your brain is continuously generating its best model of reality. Incoming sensory information doesn't create perception from nothing. Instead, it constantly corrects, updates, and constrains that internal model. In other words, your experience begins inside the brain, but it remains tightly anchored to the outside world. During dreams, however, that anchor becomes much weaker. External sensory information is greatly reduced. Your brain continues building experiences with very little reality available to correct them. The result is a dream. Some neurological and psychiatric disorders appear to involve a similar imbalance. Internally generated predictions may become insufficiently constrained by incoming sensory signals. The result can be perceptions that no longer correspond to the outside world. Scientists are still working to understand exactly how and why this happens. But for healthy perception, the balance is remarkably stable. Every second, your predictions are checked against reality, corrected, refined, adjusted. Billions of times every single day. This is why the world feels so effortless, so stable, so unquestionably real. It's important to understand that predictive processing and the idea of a controlled hallucination remain scientific models. They are among the most influential frameworks in modern neuroscience. They explain a remarkable range of experimental findings, but they do not answer every question about consciousness. Many neuroscientists support these ideas. Others believe they are only part of a much larger picture. That's how science progresses. Not by declaring final answers, but by constantly testing better explanations. Whether future discoveries strengthen this framework, refine it, or replace it entirely, one conclusion already seems unavoidable. The reality you experience is not a direct copy of the universe. It is an experience, actively constructed by your brain. And if that's true, one final question remains. Why would evolution build a brain that values useful perception instead of perfect truth? After everything we've discovered, one question refuses to go away. If your brain is constantly simplifying reality, filling in gaps, predicting the future, and constructing conscious experience, why? Why didn't evolution give us a brain that sees reality exactly as it is? The answer may be surprisingly simple. Because evolution was never trying to discover the truth. Evolution was trying to keep you alive. Imagine two different species. The first perceives the universe exactly as it truly is. Every photon, every molecule, every electromagnetic field, every quantum interaction, every microscopic detail. Nothing is hidden, nothing is simplified. It experiences objective reality in all its unimaginable complexity. Now imagine a second species. It doesn't see everything. It sees only what matters. Food, predators, shelter, friends, enemies, safe paths, dangerous cliffs. It ignores almost everything else. Which species survives longer? Surprisingly, probably the second. Because survival isn't a contest of knowledge. It's a contest of speed. Every second spent analyzing unnecessary information is another second not spent escaping a predator. Every extra calculation consumes precious energy. And energy is one of evolution's most valuable currencies. Your brain weighs only about 2% of your body, yet it consumes roughly 20% of your resting energy. It is already one of the most expensive organs your body has ever evolved. Building a perfectly objective representation of reality would demand far more neurons, far more energy, far more time. Evolution rarely rewards perfection. It rewards efficiency. Good enough beats perfect if good enough survives. Think about a computer desktop. When you drag a file into the trash, you don't see billions of electrical transistors switching inside the processor. You see a simple icon. The icon isn't reality. It's an interface. A shortcut, a simplified representation designed to help you interact with an enormously complex machine. Your perception may work in much the same way. Colors, sounds, faces, trees, distance, time. They may not be reality itself. They may be the brain's interface for navigating reality. An interface refined over hundreds of millions of years. Not because it is perfectly accurate, but because it is incredibly useful. This explains something remarkable. You don't need to understand quantum mechanics to catch a falling glass. You don't need to calculate electromagnetic forces to shake someone's hand. You don't need to understand the chemistry of light to admire a sunset. Your brain hides almost all of reality's complexity so that you can act immediately. Perhaps that's the greatest achievement of evolution. Not building a brain that knows everything, but building one that knows exactly enough. Enough to survive, enough to learn, enough to love, enough to wonder, and perhaps enough to ask questions about itself. Which leaves us with one final mystery. If evolution gave us the reality we needed rather than the reality that truly exists, can any conscious being ever know the universe as it really is? We've come a long way. We discovered that your eyes don't show you the world, they collect light. Your brain fills in missing information. It predicts what comes next. It edits, it simplifies, it constructs. Colors, sounds, taste, touch, even the feeling of a solid world all emerge inside your brain. Which brings us to the question philosophers, physicists, and neuroscientists have wrestled with for centuries. Can we ever experience reality exactly as it is? The honest answer is, we don't know. And perhaps we never can. Think about this for a moment. Every observation you've ever made has passed through the same biological system. Your senses, your nervous system, your brain. You have never stepped outside your own perception to compare it with reality itself. No one has. Imagine wearing a pair of glasses from the day you were born. You've never taken them off. You've never seen the world without them. Eventually, you stop noticing the glasses altogether. They become invisible. Your brain may be something like those glasses, not hiding reality, but shaping every experience of it. Science has given us extraordinary tools. Telescopes reveal galaxies billions of light years away. Microscopes uncover worlds too small for the eye to see. Particle accelerators probe the building blocks of matter. Mathematical equations describe invisible forces with astonishing precision. Yet every one of those discoveries eventually returns to a human brain. Every graph, every image, every equation, every discovery becomes meaningful only when someone experiences it. This doesn't weaken science. In many ways, it reveals its greatest strength. Science doesn't claim to give us absolute certainty. It gives us progressively better models of reality. Models that make increasingly accurate predictions. Models that survive relentless testing. Models that improve generation after generation. Perhaps objective reality exists completely independent of us. The stars would continue burning, even if no one were here to see them. Galaxies would continue spinning. Gravity would continue shaping the universe. Reality does not depend on human observers, but every human experience of that reality is filtered through a remarkable biological machine, the brain. Maybe that's the wrong question. Maybe the question isn't, can we ever see reality exactly as it is? Maybe the better question is, how closely can our models approach it? Because throughout history, every generation believed it understood the universe. Then science looked deeper. Newton gave way to Einstein. Classical physics gave way to quantum mechanics. Every answer revealed even deeper questions. Perhaps that's the true nature of knowledge, not reaching the final truth, but moving endlessly closer to it. Step by step, discovery by discovery, model by model. And maybe the most extraordinary thing isn't that our brains fail to show us reality perfectly. Maybe it's that 3 pounds of living tissue can understand the universe at all. A collection of cells born on a small planet, orbiting an ordinary star, has learned to ask questions about the nature of existence itself. And perhaps that is the greatest mystery of all, because there is still one final thought that changes everything. Before this video ends, I'd like you to do one thing. Look around. Really look. At the room you're sitting in, the walls, the light, the objects around you, the screen in front of you. It all feels so immediate, so unquestionable, as if you're looking directly at reality itself. But now, you know something remarkable. Between the universe and your conscious experience, there is no direct connection. There never was. Every photon became chemistry. Every chemical reaction became electricity. Every electrical signal became patterns of activity across billions of neurons. And somehow, out of all that activity, your world appeared. The blue of the sky, the warmth of sunlight, the voice of someone you love, the smell of rain, the taste of coffee, the feeling of holding another person's hand. None of these experiences exist anywhere outside your mind, yet they are among the most real things you have ever known. Perhaps that's the greatest paradox of consciousness. Your experience isn't the universe itself, but without experience, the universe would never become meaningful. Somewhere beyond your perception, atoms continue to collide.
It is a canvas of colliding
Stars
atoms,
continue
burning
to burn.
stars, and drifting
Galaxies continue to drift through space. The universe doesn't need us to exist. But our experience of the universe exists only because of the extraordinary organ inside our skull. A 3-pound network of nearly 90 billion neurons. An organ that has never seen a photon, never touched an atom, never heard a sound, never experienced color, and yet it somehow creates an entire universe. Your universe. Maybe that's why consciousness remains one of science's greatest mysteries. Not because we know nothing about it, we know more than ever before. We can observe neurons firing. We can map brain networks. We can measure electrical activity. We can watch perception unfold in remarkable detail. And still, one mystery remains. How does objective reality become subjective experience? Perhaps one day science will answer that question. Or perhaps every answer will simply reveal an even deeper mystery. But maybe that's exactly what makes us human. We are the only known part of the universe capable of wondering what the universe really is. We may never experience reality exactly as it exists beyond our minds. But through science, curiosity, and countless generations of discovery, we continue moving closer. One experiment, one question, one discovery at a time. And perhaps the most beautiful truth is not that we've solved the mystery, but that we are able to ask it. Because somewhere, in a universe that is nearly 14 billion years old, matter learned to think, to wonder, to question itself. And for a brief moment, through your eyes, the universe became aware that it exists. Maybe that is the most extraordinary thing your brain has ever created.